Hey guys, welcome back to the channel. I have another Marine ECM, this time working on a Mercury 50 horsepower EFI. This is a Motorola ECM. It's a ECM0704 from 2008. Customer concern is one of the coil triggers not working properly. So let me just get the information here, which I think I have. I have a few things that I want to show you, but let me get into the notes. I have to edit the picture 1 second because I have some information that I cannot show you. So give me just perfect. All right, sorry about that. All right, so let me just show you the computer connected in here. And that is just a note so they can see that is their computer, ECM0704, fabrication date 01/19/2008, calibration 8M0022618. All right, so in the screen now I have the notes from Connor that's getting an ECM trigger 3 short code and not able to figure out why. Parts all tested as well, and it has continuity all the way back to the ECM. All right, so that's pretty easy, pretty simple. I also have the connections for this computer that I have made. Actually, all the connections are pretty much the same as on these computers. Let me get that circle so you can get to see everything. And the simulator, that's just for my notes in there, but everything is in there. I added, because for the regular ECM55, like 4.3 liter alpha or 5 or 5.7 are the same connections, but they don't have 4 EST triggers. These are these computers that I'm working on right now. It's a 4-cylinder. It has 4 injectors and 4 coils. So this has in connector B, B15 is trigger 3, B16 is trigger 4, B23 is coil or EST trigger 1, and B24 is EST 2, which on the other setup is not present because they only use 1 trigger going to the distributor ignition module. In this case, it has 4 coils that has the triggers or the driver internally in the coil, so the computer is in control of that. So what the computer sends is a trigger signal, 0 to 5 volts, 0 to 4 volts, and we will see that in a second here. All right, so that is just pretty much for you to see the connections in there. I'm going to have the diagram, which I have ready, the picoscope, so we can see the signal, and I have the meter connected to the 5-volt reference and sensor ground. So this signal that I have right now there is actually, I'm going to change the amplitude of the signal so we can see a little better. It is around 4.3 volts. From 0, around 0 to 4.3 volts. So that is actually connected now. My oscilloscope is connected to trigger 4. So I'm going to do a test in Diagram, which is a software that we use for this. If you go over to the computer, which is, these are the values, I'm going to reconnect so we can see the full codes that he has, or they have. This computer has, let me scroll down to the bottom, a total of 473.48 hours. It has Guardian strategy for 90 seconds. So one thing that I always gather to see which volts are mine and which ones are theirs is values like the coolant temperature. Let me get that in here. Yeah, coolant temperature of 132. And then my manifold intake air temperature of 109. I haven't changed those since I connected the computer, so those are the same. So what I do now is, if I go over to the codes, let me turn that off, and we follow those temperatures, we can see the coolant on 109 and the air temperature on 129. So this is a fault that happened here. And I also want to show you the battery voltage. My battery voltage 13.03. And this is something I want to show you because they have problems on charging. So this is their temperature. It says EFT2 trigger open. So I can disregard that one because they said it's only on 3, but I'm obviously going to check all. But this is not so bad after the engine is stalled. The battery voltage is in 12.4. So that's okay. The next one, 107.89. That's definitely not mine. And it's after a stall. EST trigger 3 open. And the battery voltage on 12.25. Again, not so good, not so bad. The next one is EST trigger 3 short. And that is definitely them on their side because we have different temperatures. But look at this time, the engine is running at 702 RPMs and the battery voltage is only 12 volts. So this charging system is definitely not working. So Connor, you need to check that in the boat. The charging system is not working properly. So that is definitely a big problem because that can damage the computer. And the reason I'm showing that is because look at the next one, fuel pump circuit. Again, that's happened on then, and it happened a long time ago, like probably 200 hours ago. But look at the battery voltage. After a stall, 8.1 volts. But we can say, okay, well, that happened a long time ago. Maybe it was corrected. Well, not really. Look at this one, 445 hours. So like a couple of hours ago of the last recorded hour, 6.14 volts after a stall. This will damage your computer and it can break the computer microprocessor. So this charging system is definitely not working at all. So this is something that you need to correct, check your grounds, whatever it is, because this is definitely going to destroy the module. Look at the available power, 5%, because the battery is so low that the computer cannot even understand what's going on. And that will damage all the electronics inside. And that's what I'm actually showing that. Now we have another one with low battery, running at 727 RPMs with only 10.3 volts. And this is like 10 hours or so ago. So this is a constant issue happening on this boat. So this is definitely something you need to correct right away because otherwise this will damage the computer again and again and again and again. And that's the reason I wanted to show you that. We got another one, 442.45. This is like a couple 10 minutes or so before they send it to me. Running at 1600 RPMs with only 9.5 volts. No. This is definitely a huge issue. I will open the computer definitely to see what the problem might be. Maybe it's corroded or something. I don't know because I haven't even opened the computer yet. And if I see a short or something damaged inside, then I will definitely see that. What I don't really believe is a problem on there or on the computer yet is because look at the battery voltage now. The battery voltage, come on. Yeah, the battery voltage is 12.92 here. I'm providing around 13.4, so it has a little bit of a voltage drop, but it's staying on a healthy battery voltage. Nothing to do with like 10 or 9. If I connected the computer here and I see 9 volts when I'm supplying 13.4, well, the problem might be internally in the computer because something is shorting out and is bringing the battery voltage down. But that's not the case here. And I have, we gotta turn that one off. I don't know why it keeps going into that one. Let me close that other window. Because it's, 1 second, guys. I'm going to close that so we can see what I'm trying to show you, which is that. So right now the computer connected, I have 100% available power. That means the computer is happy, nothing is shorted, everything is connected properly, and the computer is happy. All right, so now let's do the tests on the triggers. So in this software with Diacom, I can go into tests, which is going to disconnect the connection just to do the test. And I can do the ignition coil output tests. It gives you a warning to make sure that everything is fine. All right, now we have the test in there that I can click. And I'm going to go over to the picoscope, and I'm going to start the picoscope. We're going to start with the number 4. I'm going to bring that one down so I can see, because I need to have this one here. So the coil, the oscilloscope is running. Let me move that square box somewhere else because it's on our way, right? So I'm going to move it probably here. And your view is now better. It's not in the way. All right, I'm going to fire coil 4. And I'm going to stop the capture on the oscilloscope. I'm going to stop the test. But we can see that the voltage is exactly as I described. I can put actually a measurement like that. You can see that better. Now you have the measurements in the bottom. So I don't need to have those cursors no longer, because the measurements are going to tell us how much is the lower end and how much is the higher end when that trigger is being commanded on. So we got, 400 millivolts to 4.3 millivolts. All right, let's do the same thing on on coil 3. I'm going to move you here. So you can see that I'm going to move my oscilloscope now to the coil 3, which is the one they have a problem, and it is a problem. And you're going to see that in a second. Again, now I'm going to do the test, but I'm going to press in coil 3. The computer powers up when that happens. All right, so I'm going to stop the capture, and then stop the test. But now look at the reading. It's 380, but it's only 2.1, and it's actually really weird looking waveform. I'm going to do a zoom into one of those events. Let me put a filter so we can see that signal a little cleaner. 50 kilohertz filter is fine. But you can see how that is. It's not even, it's reaching that 2.1 volt, but realistically, that signal, it's like a 1.5 volt. So it is definitely no good. Something happened with this trigger and it's damaged. All right, so we're now going to go into the next one, and I'm going to analyze it with the zoom so you can see what a good trigger should look. So I'm going to move this now to trigger number 2. Now let me plate the oscilloscope, and let me go over to that, and now coil 2. We're going to do the same thing. We're going to stop the capture and stop the activation. And now let's see. Okay, now we have the same voltage, 5.8, 4.26, perfect. And now if I do a zoom into one of those events, we can see how now that signal is completely nice square. So it's an activation of from the 0 volts to 4 volts, nice and straight up. It stays at that voltage for the amount of time the trigger is being commanded on, and then it comes down when it's released. And that is a good trigger. All right, so we're going to do the same thing on the coil trigger 1. Let me move the wire here from my oscilloscope. And we're going to fire the coil number 1. And the reason it's showing like that is because I left the zoom in. So I'm going to stop the capture and stop the activation. And if I remove the zoom, now we will see all the events that actually really happen, because I'm now capturing 1 second per screen. And the division is 100 milliseconds per division. So it's 10 divisions of 100 milliseconds for a total of 1 second. Again, if I do the zoom to analyze this one, which I can see already here that it's looking normal, and I can do a little more zoom so you can see better, which is a flat line of 0, goes straight up, it stays actuated or activated, and it comes down. That's how the waveform should look. And we might have a little bit of a difference on the voltages on the readings on the bottom, because I applied a filter before. The oscilloscope was reading any hash, it was getting lower than that or higher than that, right? So that's why now the measurements are more accurate, because I apply a filter to the waveform. But yeah, so we can definitely reproduce the concern. So the next thing that I want to do is open the computer and find out what the problem is and see if it's repairable or if we have a major problem in the computer. So let me open the computer and I'll be right back, guys. Okay. All right, guys, now good news for this computer. I actually replaced, there is like a, I don't know, like a series of BGT transistors and diodes, resistors, and all the things that should be there for protection. And still the problem is actually coming directly from the microprocessor. So the signal that is triggering that is coming directly from the microprocessor over through those components, but it's still doing the same thing. So let me just show you. I still have, you can see little components in here. I was trying to quickly, right? Try to see if I can get the signal back in shape. And no, that is exactly the same thing. Look, when I activated that signal, it is, actually, let me change the voltage on the oscilloscope. We got it, yeah, it's 10 divisions. Not sure why it's showing so small. Do it again. It is running. Let me stop that. Actually, it's not looking that bad. That's now the amplitude change. Let me try another of the coils. Make sure nothing has changed. Because at least it's looking better square-wise. Let me try coil 1. Let me make this run. Let's try coil 1. You see the amplitude in coil 1 has not changed. So if we go back to that, we can see how it's the same, you know, half a volt to 4.2. Let's try the 3 again. I'm going to stop the capture. It's looking a little better because now we have that at least a square waveform, right? Kind of, you know, because you can see how it's round in here. But look at the amplitude. And I have tried everything I could here, and it's not changing. It's the signal. It's less pronounced, but now it's a smaller, right? So you can see, and it started to go up to the 2 volts or so that we were getting before. Now I only have like volt and a half, and the signal should be 4 volts, not volt and a half. So in this case, I'm sorry, Connor and Motorbolts Mechanic, but this computer, I'm going to have to deem it as not repairable. There's nothing else I can do. This is, like I said, the damage has reached points that is not repairable. All right, guys, I'm sorry again. Well, not sorry. I think it is part of of repair sometimes, right? I mean, you cannot expect every single component could be repaired. And what I always do, and I have expressed this in multiple videos, is I have to stop to a point where I am not losing, because it's going to reach a point that is going to be more expensive to repair this computer than to buy a new one. And I don't want to do that, right? Because I charge this customer $1,500 to repair this computer. Like, what? You know, I can get one for like $1,600 or $2,000. Why would I pay that for a 20-year-old computer, right? So that's where I stop. I gotta make myself aware. And yes, I spend, you know, more than what I should have done or spent on this computer. But like I said, I always try to go, I go a little extra just in case I can correct it, and then, you know, not be too expensive, because then I would not just charge a test fee. I would just charge the repair costs. But it's not the case in here. All right, guys, thank you so much for visiting the channel. Don't forget to subscribe. See you next time. Bye-bye.